Welcome to season 11 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal is to share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you're here and hope it is the highlight of your day.
Hi, everyone. My name's Joris Peels, and this is another episode of the Prosthetics and Orthotics podcast with Brent Wright. How you doing, Brent?
Hey, Joris. I'm doing well. I think I'm actually probably feeling better than you at this point in time.
I hope
so. You want to share why you might be a little bit under the weather there?
Yeah, so I had a root canal this morning. So, this morning / afternoon. So, great experience as always.
Well, I know we were talking, and I think this is just the interesting thing about, healthcare in other countries. I mean, in Spain, it sounds like kind of one of the things is cash is king when it comes to this point, which also means that it can bring down pricing of root canals or any dental work for that. I haven't seen that go into the orthotic and prosthetic space yet, but I wouldn't doubt that is coming. But we might actually be able to talk to our next guest about that because that might have some insight.
Okay, guys, who's on the show today?
Well, I'm super excited to have Ashton Stoop on the program today. He is from Canada, but has found himself in Mexico, and he is building and 3D printing prosthetic legs. He has connected with a clinic down there and has helped them on their 3D printing journey. And I think one of the things that I've enjoyed talking with him about is just how to approach some of the problems from a technical standpoint. And then how do you take that technical standpoint as well as the clinical standpoint and, quote unquote, artistry and create a product and make a difference in somebody's life. So I'm excited to hear more of his journey. And that's going to be fun.
Super exciting. Okay, so Ashton, tell us, how did you get involved in O&P?
Hey guys, thanks for having me. So my journey into the O&P industry came more through the side of engineering and product design. So I was studying mechanical engineering, and I was a really competitive rugby player for a long time. And I started following this path of wanting to go to Nike and wanting to design footwear. And I reached out to one of the people running the biomechanics lab at Nike, and he told me, if you want to design the best shoes, you should study biomechanics. If you understand how the human body works, you can build things to augment and to elevate it. And so this kind of brought me into a biomechanics lab at my university in Canada. And I started working first on a lot of computational modeling. So taking a bunch of CT and MRI scans of the bones in the hand and the wrist, moving through different positions and seeing how the bones move compared to the ligament laxity of the wrist, and then later doing similar studies with the foot and the ankle. So my kind of first step into the world was really through the lens of biomechanics and starting to work in gait labs and tracking how the human body works. This is a field that's pretty related to O&P. And so as I started getting further into this field, doing more research, also joining a design team at my university, which was focused on designing medical devices. And when I joined this team when I was 18 or 19, one of the first things they were working on was a knee, ankle, foot orthosis. And the concept was to create a very low cost version that you could ship in a box that was hyper adjustable. So you could ship it in a box and it could be fitted and adjusted on site. And at the time, I really didn't know anything about the O&P industry. I was really wanting to do shoes. And so I joined this team and I started kind of building a shoe on the bottom of their CAFO. But that was actually my first step into learning more about O&P and about assistive technology. So that was step one. I did that for about 3 years. I later went and did my master's of biomedical engineering, starting to get more focused in O&P, starting to work with some clinics in Rhode Island, people who had been designing components for Becker, people who were running small O&P practices. That's when I first got introduced to 3D printing with one of the clinics I was with in Rhode Island. He was one of the kind of early adopters over 10 years ago of starting to put pretty simple scan and print workflows with Delta printers. And so I was pretty young and coming in from the side of engineering and design and building. And some of my early kind of inspirations at that time were people like Scott Summit, who were, he was an industrial designer and I think was working early days for E3D, had access to scanners, to printers. And so he was doing some of the first conceptual designs that I had seen of 3D printed prosthetic legs and, parts for robotic exoskeletons. And so that was always really fascinating to me to see this approach of kind of blending product and artistry applied into this field that is more focused on tech and biomechanics and getting people into walking into movements. And then when I finished my master's, I got brought out to a company on the west coast of Canada called Human in Motion Robotics. And it was a robotic exoskeleton company for people in wheelchairs. So it's the most advanced exo in the world right now from what I've seen. It's 12 degree of freedom robot, meaning that it has 3 robotic actuators at each hip to mimic a ball and socket joint, 1 at the knee and 2 at the foot and ankle. So these 12 motors, a person in a wheelchair can get inside this robot and can actually go up and down stairs, up and down ramps, turn in place, squat, side step, dance, all kinds of features. And so this was kind of my next stage of bringing like tech into O&P. And that ultimately led me to Mexico in end of 2021. I kind of found my way down here almost by accident and kind of stayed on a whim. And that's where I got connected to a big O&P clinic down here where we started working together to see how can we take some of these ideas of 3D printing and start applying them there.
Okay, super cool. I love what Scott did in making kind of beautiful prosthetics and really inspiring people, actually making them also work, which is also important always, but also this whole idea, this beautiful prosthetic thing where it's like, no, it's like, it's not a bug, it's a feature. I think that's an absolutely wonderful thing that he did for everyone.
Yeah. I mean, that's one of the things that I speak a lot with the doctor at my clinic now. We talk about what matters, what's important. And I think one of the things we've come to is about, prosthetic covers is something we started doing more. I've started kind of producing custom ones based on what the patient desires, what they ask for. What do they like? What do their family think of them? How are they perceived? And how can we make a cover that embodies that? Because at the end of the day, one of the most important parts of a prosthetic leg or a prosthesis is that acceptance and that emotional integration. And so we see the cover as a tool for integration as well.
And talk us a bit about also like, all this biomechanical stuff, because it's kind of weird because some of it is just available in textbooks and all this and it's lying around. And then some of it is completely proprietary and people are just keeping it to themselves. Do you think that should be a little bit more evenly distributed, or it should be a bit easier to access all that biomechanical data? Or you're like, no, that's just, somebody did the work. They need to kind of keep that to themselves.
Yeah, I mean, I'm a fan of open sourcing a lot of the information, especially in an industry like O&P, which is very social impact oriented. But also from what I've seen of biomechanics in the industry and academia, it's a really complicated field. And I say this because even as advanced as research labs are getting now, there's still so much that we don't know about biomechanics altogether. So when I was doing these research studies specifically on the hand and wrist and the foot and ankle, at the time, this is around 2015, 2016, these were really considered a black box in science, because if you look at the density of, the foot and ankle, there are so many bones and so many ligaments packed into this very small condensed space that it's hard to use simple studies to understand them and to learn about them. So if you're going to work on the knee, for example, and you take an MRI and you do a bit of movement, you basically have 2 big long bones, and then you have the patella on the front, and you're really just tracking the movement between these 2 bones over a large distance, which is not that complicated. But as it gets more into the foot and ankle or the hand and the wrist, just in your wrist, you have basically 15 bones in this kind of 4 centimeter span with so much density packed over top of them. So there's so much debate in society in the academic world of biomechanics of how the foot and ankle, how the hand and wrist even works, how do the bones even move, even discovering what patterns are true and consistent. So I think more so than it being, gate kept and needing to be democratized, I think there is just a more fundamental level of understanding of biomechanics that needs to be brought together to everyone before it can be shared.
Yeah, it's crazy that we don't understand this, right? You know what I mean? Or the little amount of understanding we have collectively on this. I think it screams for something where we should just have this giant open source project to share all this and really kind of make it more available, at least for certain things. I think there's always somebody trying to make a $50 prosthetic leg or something. But there's nobody trying to enable hundreds of people to make $50 prosthetic legs. Some kind of open source tool that would do it all. So
are you volunteering yours? I mean, that sounds like an amazing project for you, right?
No, it sounds like something it's like a good decade of your life that may work. So I understand why it's happening.
Well,
I
mean, we should just let's. I don't know if Ashton would be willing to help us flesh that out, but let's have a quick discussion about, hey, do you think that could actually work?
So what's the topic specifically?
So essentially creating a consortium on low-cost prostheses. Instead of having these kind of siloed projects, everybody has their own 3D printing project and NGO and that sort of thing that's going on. Can we get people together, or is it too far gone?
Yeah, I think this is one of the bigger questions right now. And for someone like me, for example, I really came from outside the industry, from the lens of product and tech and engineering. And it's been a pretty difficult challenge, I would say, in a lot of ways as a young person to get into the O&P industry. I think there's a lot of barriers, there's a lot of red tape, there's a lot of people and information being siloed. And where I'm at now in my career is starting to connect more and more with different people for this topic specifically, to recognize there's a lot of these big kind of monolithic players that control the industry in certain ways, specifically when it comes to manufacturing. But I think what is happening now with the advances of 3D printing and software capabilities, it's going to open that up a lot more for small clinics and practitioners and individual designers to have a lot more impact in what they create. And how do we bring these people together? Something that I am a part of now is a Discord channel called the Digital Limb Collective. I don't know if you guys have seen this, but it's been going for about 3 or 4 months now. And I think there's almost 100 people or maybe more at this point in this Discord channel just talking about how can we share information? Hey, what materials are you printing on this printer? What worked? What hasn't worked? And that's been, I think, a really powerful pillar so far of starting to share and democratize what is working and what is not working. And I think there's, levels beyond even to say, how can we align to larger scale projects, 1, 2, or 3 kind of big challenging things that individually we haven't been able to solve, and how can we come together and make some progress on it?
I think that's interesting that you mentioned the Digital Limb Collective. I think it's an interesting forum, and there are so many good things on it. I am on there. I'm old. Okay. So Discord is not my thing, but I am on it. I don't even know how I got on it. I think I clicked a link and then there was hey, you want to connect something? And then all of a sudden I'm in the Discord channel. So, but what I love is that there is a passion specifically for FDM and FDM concepts, materials, that sort of thing. I did want to just, on that, and it just from the outside looking in on some of this and coming from, I'm moving back towards, I really like FDM. I love some of the things that are coming along with it. But the aspect of, this idea of low cost, consumer grade, Amazon bought, creating, medical devices. Can it be done? 100%. Is that the right thing to do? Well, it can be done. So I don't know, so I struggle with that somewhat, because not that people that buy, say, a Bamboo A1 Mini may not know the implications of, hey, you're doing a 6 millimeter socket with a 0.4 millimeter nozzle and over 4 millimeters of gyroid infill, and that's just not going to work. But they don't know that.
Yeah, I think that this is maybe where it calls into place the needing for some standards and some regulations. And I think you see this a lot when an industry changes quickly. It becomes a bit of the Wild West. Like 3D printing has been involved probably, for a decade now, or even a little bit longer on the fringes. And now it's becoming a bit more mainstream. The average clinic is giving it a shot. And I think there's all kinds of small players out there, entrepreneurs trying to sell to the clinics, trying to sell 3D printing. And there's a big knowledge gap from both sides of what is possible and what works and what we should do and what we shouldn't do. I do think that the fact that it's starting to work from an FDM standpoint, that you can buy like a $500 FLSUN V400 and put some TPU in there, and you can actually make a decent socket that people can use, and even potentially a definitive socket from that. But then where's the threshold of, what happens with quality control? Are there certain parameters that must be used every time this socket is created, but not others? I think that it's a powerful tool that it's becoming more open sourced and more accessible for the average person to do it. And I think that is going to be an important thing for the industry, because it brings more power back into the hands of the clinicians in the small practice in an economy and ecosystem right now where it feels like these large monolithic players are getting more power and are eating up more of the clinics. I think it's a bit of potentially a level playing ground for them to take some of that authority back. But I do think that standards and regulations have to go in place to keep it consistent, mostly for the sake of safety of the patient.
Yeah, I think the safety is super important, but I think you nailed it in that a lot of these big companies, they're watching and looking. So I'm thinking like Oser, Autobach.
Yeah.
I know I'm missing a few. What are some other ones? So the big company, Hanger, they do have 3D printing on their horizon, and I know some of them, but there's not necessarily a plan, and it moves so slow because they may not have the right people in place, the team. Or to me, this is still the big one, is that traditional fabrication is such a cash cow for these companies. It kind of moving to 3D printing not only is a big move, but it kind of cuts the traditional fabrication out at the knees, which makes them a good amount of their revenue. And I think that's why some of these companies move slow.
Yeah, I mean, if you look at that story, how it's played out in the past in adjacent industries, I think a really good example is Kodak. Kodak, the film, the camera company, because historically they were the first company that invented the digital camera. They had it before anyone else, but they were so aware that about 75% of their revenue was coming through the sales of film itself, that to start selling the digital camera would undercut their business completely. And so they shelved it until all these other companies came out and started putting the digital camera forward, until Kodak basically went bankrupt because they were the last to join the digital era, even though they were the first one to have it. So I wonder if you're maybe going to see some version of this happening in O&P as well.
But I think your point, small clinics have an amazing advantage to be movable, nimble on this 3D printing side, and create really a differentiator in their local market compared to some of these bigger companies. And I think that's the real neat thing as of right now.
Yeah, and I think that edge is needed more than ever right now, because if you really watch what's happening in the US and Europe, and even starting to happen down here in Mexico and Latam, is these, Autobach and Oser now have their own clinics, their own services, and they're starting to acquire other small clinics and pressuring them and moving in next door. And so if these smaller clinics aren't able to find an edge, it's going to get harder and harder to compete. And I think that this is the moment to break free from that.
No, it's all, and we see this as well in dental, right? Where small, either practitioners or also just smaller companies in the dental market are innovating and outpacing the larger ones. And also the same in bicycle manufacturers. It's not the Shimano's, Pirelli for a little bit, I guess, but it's not the really, really big companies like Trek and stuff that are innovating in bicycles. It's just really smaller shops because they have to and because they can, because it's just like, hey, do you think it's a good idea? Let's try it, Now imagine trying to do that, a giant, this really big bicycle company. It's it's much more difficult. And then we saw it also, we see that in orthopedics as well, right? Where the big companies just keep on making their products, and then they keep buying the smaller ones that are exploring, that are successful in exploring new markets. So I think, that kind of totally, we see that in O&P as well, right? Where you make a cool thumb and then you get bought for making cool thumb, or like Filament Innovations, right? They make a really robust, really large, cheap to operate material extrusion machine. They get bought. That's kind of like what's going to happen here as well, I think.
Yeah. Yeah, I can see that. I think it's also good to look at adjacent industries and what's happening there, especially, Brent, you mentioned with access opening up more to FDM printing. You can buy it on Amazon. It's, $280 for a Bamboo A1, et cetera. Is FDM the right way to go? Is that going to surpass the use of SLS, multi-jet fusion? Is there room for resin in this ecosystem? I think it's still hard to tell. There's a lot of advantages of looking at like the carbon and the form labs, but also a lot of challenges of curing resin, et cetera. But I have been looking a lot into the footwear industry, and there's a really cool company called Zellerfeld. And I'm not sure if you guys have seen this, but they're a fully 3D printed shoe company. And they've been kind of casually working on their R&D for about a decade, based in Germany. And now they are actually growing quite big and have a lot of big influencers using their product. Their sales are growing quite a bit. And it's a fully FDM printed shoe. And they basically built these custom machines that are a little bit bigger of a build volume, have a little bit thicker of an extruder. It's a dual extruder. And it's basically printing TPU with dissolvable supports inside. And it's maybe a 20-hour print time to print a shoe or pair of shoes. But these are now on the market as a real consumer product for $200 or whatever that people are fully paying for. So for me, I'm kind of watching these adjacent industries and seeing that so far, I actually would say FDM is starting to take the lead as a consumer product manufacturing technique.
I don't think Zellerfeld has actually done anything meaningful R&D until very, very recently. And I think the meaningful stuff they have done is in the materials stuff, and that material stuff, as far as I can understand, comes from Color Fab. So I think they did the real work. And basically what they did is they took a tool changer, E3D tool changer machine, and they are now writing their own slicing software, which of course is really, really very exciting. And going forward, that plus if they develop pellet based, that could give them a real advantage. I think it's a really good platform play. They're incredibly good at marketing. They're really incredibly good at marketing. And they're really incredibly good at charming people into working with them. So I think the funny thing about that is that Zellerfeld till very recently didn't have any technology apart from the fact that it is able to seduce really large companies into working with it, which maybe is enough. You know what I mean? And so I think it's also interesting for different reasons than you do. I think they're interesting because, well, maybe it isn't about the shoes, or it isn't about the print technology, or it isn't about the materials technology, but it's actually about charming companies or being the go-to source of companies. You know what I mean?
Yeah.
So it's a bit kind of, but I do like the example. And I do like the fact that what I love about them is that the fact is they were working with a couple of really big brand name companies. And a lot of people would have just stopped doing that and just, hey, we're just going to do manufacturing for Chanel shoes and all this stuff. And instead they went the YouTube route, where they're doing the YouTube thing for shoes and you can upload to them. I think that's a much more longer play. They've got a lot of investor money at the moment. Let's see if they use it usefully. And if they do pellet and they do a really intelligent slicing specifically for their TPU materials, right? So they're building a slicer, not for any TPU, for pellet TPU that they use, in that color. I think that could be a really exciting play. And they build then the printers a little bit more sophisticated way than they're doing now. I think it's very interesting. And I think they're quite unstoppable at the moment, even though there's nothing really there. So I think that's quite an achievement, I think.
Yeah. And what do you think about that case study when you talk about how a big part of their leverage is really their marketing play and how they're able to seduce big companies into working with them? What tips do you think that we could borrow from their case study and bring into the O&P industry?
See, the funny thing is it's this Jobsian kind of play, right? And it's this kind of like I am the mystic kind of play. And that's not something that I normally, if I'm doing like a due diligence type of thing, I'm like, yeah, that's their big thing. The what is that, Bankman-Fried-esque kind of ability, right? But it does work, right? So, if you have a person that raises funds really well, you're going to do very well in the 0 to getting $20 million phase, Mm-hmm. And that kind of a pitchman thing, we saw that happen with Rick Phillip, for example. He's incredibly good at that. He's incredibly good at going to a room and investors and either soothing them or getting them to fork over more money. And that's a skill. That is a skill. I can't do that. I don't know very many people that can do that, right? other people that can really talk well to Wall Street or really talk well to banks and really do a really nice M&A kind of stuff for the big companies. But he's specifically that. So if you have a person that has that kind of charisma, mystery kind of thing, that's a bit over now. People are more into kind of like, he's a boring founder, she's a boring founder, she's been doing this for 20 years. But if you can cultivate that mystique and you have that ability to pitch and you collect that team around you, that's good. And then the other thing is, I think this is a bigger point. We could maybe do a whole episode on this, but I think they're in Hamburg, right?
Yeah.
And there's this book I read once, and it's like and basically the thing about it is chance favors the connected mind. And they were basically saying that you need to be in these connector places like New York or Silicon Valley to really innovate. And I used to live in Eindhoven, where ASML kind of came from there, and Philips and a lot of other companies came from there. And Eindhoven was the middle of nowhere, right? And they innovated because it was the middle of nowhere. And I think the fact that they are able to charm the footwear and the luxury goods industry into working with them, but they're isolated on their own little island, away from the 3D printing crowd, away from the Berlin cool fashion kids crowd and stuff. That I think is a wonderful idea, right? And I think that gives them enough incubation and enough kind of either the ability to soak up locally that kind of attention. Now the other thing is, if you talk to shoe designers and stuff like this, I was doing this stuff at home. Brent was doing this stuff like way before I was, and my girlfriend even did like a class, and then did printed TPE shoes as well. So I was just like, it was not really special to me. But if you took these footwear designers that have a ton of experience, right, and maybe even have a ton of 3D printing experience, but at the same time they really really look up to the Zellerfeld dude as like this kind of visionary. So he has also that ability. So on the one hand, the investors like him and he can pitch to, and that's one thing. The second thing is he can also pitch to Louis Vuitton or whatever. And the third time is he can talk to a shoe designer, and the shoe designer doesn't feel like he's an arrogant prick or something. He just feels like he's like the good guy to talk to. So I think that's an ability that I think is very difficult to find that in one person, to be able to charm those people. And I mean that in a positive way. And I think that's just like, I know like literally dozens of people that could have founded that business. But I don't know anyone that would have been as successful as he was, not because of their ability as an engineer or as a business person per se, but it's just that was the thing. So the lesson here is that, or that's a kind of a classic lesson is if you would be a brilliant marketeer and you join Procter & Gamble, you're going to be surrounded by brilliant marketeers, right? You'll learn, you'll be a darn good marketeer. In 1-2 years at Procter or Unilever, these kind of companies, you'll learn a ton, right? But if you join like waste management or, I don't know, something like really boring, like a recycling company or something that's B2B or something like that, you'll be the only marketing person. And you could really change that whole industry by just doing how they market their product. So it's about being the different person in a very typical kind of a market. So I think that's interesting. But to me, it's just a founder story more than like a startup story. I think anyone would have done it. Everyone would have done the same way. I would have done the architecture of the printer differently. I think Brent would have done it differently still. Other people would have maybe gone with powder bed fusion or something like that. But it's basically the same startup everyone else would have done. But I think it's this one person's mystique that really makes it the successful so far.
Well, I think one of the things too, Joris, though, is that it sounds like you're saying that they're investing into not only materials, but slicing. So that's where their intellectual property is.
Well, it's smart. I mean, it's smart. It's smart. Yeah.
And that's hard. Like, it is really, really hard. Now that we have this polar printer out and I've been doing some non-planar stuff and trying to get seams right and flow rates right and all that stuff. Like that in itself, those learnings are so important. And there's not a lot of people that have the willingness or the willingness to go through pain to finish some of that stuff up. And so, I'm excited about that. The marketing stuff is always very interesting to me because I think you see that somewhat in the prosthetic and orthotic side of things. Very early on, Standard Cyborg got bought out in 2018. They had an iPad app. I mean, still to this day, that app hasn't changed with what they're doing. It was very effective and people still use it to this day, but it hasn't necessarily evolved. But they had cemented themselves as a leader. But once they're gone, it's hard for somebody to come in and pick that up and keep stuff going, it's kind of like Mesh Mixer, right?
Yeah,
it hasn't changed, but it's still very, very useful. And a lot of people, if that Mesh Mixer goes away, a lot of people's businesses go away.
We need to start like do a whip around money and stuff and try to fundraise a new version of it or something.
That would be awesome.
In trouble. No, it would be awesome. Yeah. We should do this. And then hire Chris Schmidt for a year or something if we can afford to.
Yeah.
That'd be awesome. Anyway, so talking about apps to make legs, it doesn't actually have something like that or something like that, right? You're also working right now on a leg that like a customizable leg kind of thing that you made using 3D printing, right?
Yeah, it's a work in progress. So with my company Adapt, it's really been kind of a creative design studio for the digitization of O&P. And that just kind of means working on a number of different things at once and exploring what works, what doesn't work in the clinical application. So a big part of what I was doing early on was 3D printing transtibial sockets. And with my clinic here, we have a number of patients doing different tests of check sockets, definitive sockets, both using FDM techniques, multi-jet fusion as well. And as we were starting to get more reps, we were trying to figure out how to speed up that process, because probably like my first process would be, I think in the early days, I was using Omega willow wood for doing my clinical mod. So scan goes into willow wood and then bringing it into Mesh Mixer for cleaning it. It's a little bit limited in Mesh Mixer, but you can still kind of get most of what you need, and then putting that into a print. And that workflow was a little bit tedious for me and didn't give me the ability to make all the small, subtle tweaks that I really care about as a product designer. All these little things about like, can you roll the edge of the socket out? How do you make sure that the alignment is correct and everything with the adapter? Just all these little tweaks I wanted to do didn't really let me do it in that workflow. So I started building my own process of doing this. When I was in grad school and I was doing my master's of biomedical engineering at Brown, down the hill from Brown is RISD, the Rhode Island School of Design. And they have a really top-notch industrial design program. And I was lucky enough to go down there and get to take accredited classes during my master's. And I started meeting with a lot of these designers and working together. And I noticed that in the industrial design world, everyone that I met was using this program called Rhino for 3D design, which in the engineers world, you don't use it as much, because something like Rhino, you can just grab a surface and pull on it and move and expand it, which if you were, a mechanical engineer and you're in SolidWorks and you want to do that, it won't allow you, because the part has to be made following certain mathematical sequences to allow for machining to follow that path. But with these industrial designers who are making a lot of renders or 3D printing or whatever, they can just kind of pull on surfaces and do whatever they want. And that really caught my attention, because it felt like this kind of unlimited workflow where you can sort of push and pull and do whatever. After a few months of getting into Rhino, I found Grasshopper, and that really opened my mind, because Grasshopper, for those who don't know, is like a back-end side of Rhino, this 3D modeling program, which lets you create automations and repeatable workflows. And so it's kind of like a no-code web of processes, where I started playing with this idea of, can you just take a 3D scan, put it in the first node in Grasshopper, and then create a whole procedure, which was what your clinical changes would be for any patient. Scan goes in. First thing, maybe you want to adjust the circumference measurements. Then you want to maybe do like a small distal extension. You maybe want to put some pressure around both lateral sides of the tibia. You want to alleviate the front side of the tibia. All these like standard clinical modifications. Could we just create these repeatable workflows inside Grasshopper, that you have basically a system which designs a socket with all of the steps included. And all you do at the very first node is plug in the new scan every time you have a new patient come in. And why I like doing this process is it's different than Mesh Mixer, because it's not a mesh process. It's not these triangular surfaces. It's these NURBS analytical surfaces that are computational, that are defined by these mathematical formulas. And it gives you a higher resolution product, and it also gives you more ability to make adjustments, right? You can go and like adjust the circumferences and then do 20 other steps. And at the end, realize that your circumference measurements were wrong. And instead of redoing that process, you just go to the first node and you move a slider, and it's made that adjustments, and everything else worked accordingly. So that's been a project I've been working on for about 2 years now, is starting to automate a lot of these processes in Grasshopper. And we're starting to make some progress. We kind of have like, we use it internally in our workflow, and we can do a socket in 5 to 10 minutes, sometimes faster, just using these workflows. There's little pieces we're still cleaning up, but it's been a really good experiment. And I think that there's a lot of potential in that direction. And it has some benefits that I haven't seen from other existing 3D workflows for sockets.
I like the idea of the Rhino Grasshopper workflows. I think they're super powerful. And I don't know that we've really talked about that on the show. You covered it a little bit.
It's kind of crazy. It's kind of crazy because it is something we discuss and we use it ourselves, right?
That's right. So I'm kind of curious though, like from what you've seen, I know like organic shapes are difficult, whatever the software is. What are some of the, definitely the positives, but then can you just share with our audience, what are some of the hurdles that you've had dealing with, these ideas? And I'm thinking specifically around the Booleans and fillets and smoothings and that sort of thing.
Yeah. It's, I mean, you guys know well, but it's one of those things that seems like a great idea until you really get into the errors. And I've been in that position where I've had a whole product designed in like an hour or two working on a wrist brace design for a patient, and it's perfect and I'm stoked. And then all I have to do is fill at the edge. And took me like 3 days to go back and fix all this stuff. And so it's one of those things that to me is a bit non-intuitive at times, because you can go in and do certain things, but because of the logic of the software of Rhino itself, the back end of how all of those modeling tools work, sometimes you'll arrive at a point where you're stuck on, like you said, a Boolean subtract, or simply filleting an edge, or everything looks good, but there's maybe like 2 surfaces that overlap somewhere by 0.5 millimeter and you can't see what it is. And then you have to go into this whole debugging phase, which sometimes takes longer than making the model that you made initially. So I think some of the things that I really like about the Grasshopper workflow is, like, if you can get it to work, to me, it's the most dialed, most streamlined workflow of any of the softwares, any of the digital workflows I've seen anyone use. It has this sequence of nodes, which gives you exactly what you need to do, gives you the ability at each node to make small tweaks, small modifications to your process. If you can get it done correctly and you use, the right logic, you can literally just plug a new scan into the start, make a few minor tweaks, and you've repeated your whole, not only clinical modification like you would do in something like Nomad Sculpt, but also the next step of that, which is you take this clinically modified, form, and you've turned it into the actual 3D socket, meaning it has walls, it has thickness, it has at the distal end, it has, its suspension system or whatever it's attaching to. So you can automate that whole process from scan to like printable product almost instantly if you can get that workflow dialed. But the challenges along the way are these very small, subtle, mathematical, analytical problems that happen in designing that repeatable workflow.
Yeah, I think Grasshopper is like an incredibly powerful tool, I think. And it's an incredibly powerful tool, especially also for designers and and also for if you would be like the CAD expert and you want to work with me or whatever, somebody who's not the CAD expert, that allows you to operate on multiple levels. Have like a user person that can do a kind of workflow that you implement quite quickly, repeatably, very easily, without understanding why that workflow exists. But yeah, you're right. It's kind of like painting with a roller. It's great, super fast, and then you get to the corners and you're like, oh, now what? And then you don't know how to paint. And
exactly.
Love that word picture. That's exactly right.
This is totally it. This is totally something, but it is a really, really powerful. Would you recommend to other people? I mean, you guys have understood this now. If I was doing something similar, if I wanted like an app to make my own legs or whatever.
Yeah, I wouldn't, like, if you're one person and you want to, start doing your workflows, I wouldn't recommend going the Grasshopper route unless you're an extremely crazy, disciplined, hardworking person who's going to spend the next 5 years on this side project, because it's not easy to pick up Grasshopper. It took me, 6 months of working on some different products to get pretty comfortable in Rhino, which is just a slightly different modeling process than I would in my more mechanical background doing SolidWorks. But even years into it now, I'm still not actually the Grasshopper expert. I bring in developers when things get complicated, and I have people who kind of work and doing those edges for me that I can't always get into. And even these guys that I bring in who are experts, they get stuck sometimes for a few days at a time. So there's like a pretty steep learning curve, but that learning curve goes for a long way. It's a very deep process that you could get into for your whole career to just be a grasshopper designer. So it's one of those things that I think, and it comes back to maybe an earlier part of this conversation, is where can we collaborate? Because I think for one individual, it's too much. It's too complicated. At my peak, I probably had 3 or 4 of us in there in this grasshopper file working on different parts, trying to get all the pieces together. And it was months and months of 3 or 4 of us going through different iterations together just to get it to where it is now. So I think that it would be, it's useful if you're someone who really wants to come and work on that specific part of the process for the industry, if you want to work on like workflow optimization. But if you're just an individual hobbyist or a clinician, or you have a small O&P practice, I wouldn't really recommend the average person to get into Grasshopper because it's just so over the top. But if we can bring together groups of people, collectives, like maybe there's, a collaboration. And here, I think Brent and I actually have a call later today to talk about Grasshopper on some stuff. And if there's some ways that people can come together and share and co-create and share the burden of the complexity of Grasshopper, I think it's really great. But I think it's a lot to take on as an individual.
Yeah, I mean, and the other part is like, so you have some of the node-based stuff, but then it really becomes this, it's a programming/math problem. And so the people that are actually really successful at the Grasshopper automation stuff are a combination of programmer math wizards, because that's what it becomes. And so I think one of the things that we found too, and what I really appreciate you saying, Ashton, is that it's a group effort. So these mathematician designers, if you have a workflow that works in its current form and it's not necessarily Rhino Grasshopper, they can take that and automate it. But they can't, like if you say, hey, I want to go from scan to a finished socket, they wouldn't know where to start. That is where your expertise comes in. And then that's where this kind of collaborative effort comes into play. And I think, Joris, you and I talk about this a lot. So many people think, oh, I need to go learn Rhino Grasshopper, or I need to go ahead and buy the printer or whatever. And the real question is, do you have a product and somebody to sell it to? And if the answer is no to either one of those, then why are you doing it? And I think that's a really important thing. And I think that's what I appreciate about what you're saying there, Ashton.
Yeah, I think and there's a bigger point. There's an interesting point. It was like, remember the enable hand thing, but the previous iteration of enable hand was a very chaotic, all over the place group of people doing what they hope were good things, but sometimes being, it was all over the place. It was a really chaotic time. I remember that my boss at the time, Erik de Bruin, who's a co-founder of Ultimaker, he wanted to get involved, and we were spending a lot of time helping them essentially. And Eric wanted to make a customization tool to make all of the enable hands parametric. And then we looked at this design to make these hands parametric and stuff. And we found out that there was like all these issues with it, but we found out that the actual number of sizes for the enable hands was not that infinite. Mm-hmm. It was just about like, for most people, you could just get like, I don't remember, I forget what it was. It was like 10 sizes or something. So the whole idea of building this customization engine, right, was actually kind of like, we didn't have to do it. It didn't actually make sense to do it for this enable hand, because we just had to make, 10 different designs or 10 different sizes, and then we were done. And then you measured the patient, and then whatever the centimeters was fit in that design. Now, it's a different discussion as to how well the enable hand works and all that kind of stuff. It's better than having nothing. Let's put it that way. But I think the before you do this whole customization software thing is, do you need it? And we had previously also at Shapeways, also later at Materialize, we spent a ton of time. Once we developed this product, we spent months making a customization tool, and nobody bought it because it just wasn't a beautiful thing. And we developed this customization engine for it. It was like, and other times people would have bought it, but then people would have just, they didn't buy it enough. So at one point we had this cufflinks, and we're doing 3D printed cufflinks. We're customizing them. And then what we decided to do there, I think it was Peter Paul came up with it first, but just the idea of like, we hire a whole bunch of dudes, right? And then every order that comes in, the guy just customizes it. And we just print out a bunch of different names, take the pictures of them and put them in front of people and say, this is the design. And then, yes, you'd have to, visualize the name on it, right? And if you do order it, then we'll have a guy somewhere around the world make the CAD for you. And that was, of course, a much faster way, right? So we didn't spend 3 months and $50K making this engine. Instead, we just offered the product. If the product didn't work, we kept on going. And then once the product worked, then at one point we would maybe make this customization engines if we were hiring like hundreds of guys to do this. I think it's just because you see this vision of the workflow doesn't necessarily mean you have to spend all of your time making the workflow. You could just make a leg for a certain patient or a certain size patient, or just focus on a different thing.
Yeah, this leads me to a question that I think about often that I would love to ask you guys, which is, there's kind of two main ways to approach this from my perspective as a designer, developer who's working on workflows. One is I can put all of the choice in the hands of the clinician in how they do the clinical modifications. So a workflow that some people are doing right now is where a clinician has Nomad Sculpt on an iPad, where they can take a scan, they can do all of the clinical mods in the way that they want it there, and then it gets sent to someone third party who turns that into a socket and produces it, etc. So that's one side where the clinician basically fully dictates what is happening with the clinical modifications. One of the challenges with that, though, is that every clinician has a different process. Even if you go to 3 of the best, most experienced practicing prosthetists in the world, they'll probably have different ways of doing the sockets for the same patient. The other way is when you look at how AI and machine learning works, is it's really a lot of like reinforcement style learning, meaning that if you have, if I were to run experiment with 1,000 patients at my clinic here in Mexico over the next few years. And every time a patient comes in, I take a scan, I do the clinical modifications digitally through Grasshopper, I print it, I fit it to them. Maybe I have to still heat mod a little bit. And you do these manual touches until you get the fit that actually works. And then you scan it again. So you had an input, which is your raw scan. It's gone through these changes both digitally and manually through clinical heat mods. And then you end up with the final product, the definitive that fit, and you scan that. And now you have a data set of what was the initial hypothesis out of Grasshopper, what was the initial scan, and what was the definitive that worked. And you can now train a data set. And you do that hundreds of times or thousands of times. And you start to be able to train a machine learning model, which can recognize based on this person's height and weight and based on the scan, it is likely that it's going to need, a little bit higher support above the condyles, and it's going to need a 5% global volume reduction instead of a 4. And this one needs no distal extension, because you've trained that data set enough to recognize what is working in that collective set of patients. And so one of the questions that I think about a lot is, how much do we want to leave that level of control of all of the clinical modifications in the hand of the individual clinician? And how much of that do we want to try to start systematizing and create more repeatable processes that can be followed by, larger groups and larger clinics, and creating more over the long term of soccer production?
Oh, there's a lot there, isn't there?
Yeah, there's a lot there. I'll answer the broad structure. I'll answer very differently, I think, than Brent's going to give you the real answer, but I'll give you the answer you should do. Definitely do the AI one, because that'll give you more funding. Right. So if you just have that would be the way for you to get several $1 million for this, would be to go the AI. We're going to do it with AI, and AI is going to do everything for us. Right. The other thing is, let's think a little bit further and say, how about we take all the data? And we were talking about this before. Some people are going this route as well. How about we take all the data from the patients afterwards, how comfortable they were, how often they used it, when it broke, that kind of thing, and the reporting from the person, and then feed that back into the model to see why people are happy and why they're not happy, right? Yeah. And that to me is, then you've got something very, very interesting, because then you're saying, wait, if we do X, or biomechanically, this is what's happening. Or why, you'll find all of a sudden that there's some people who, I don't know, maybe they feel pain a little bit more, or they feel pain a little bit more in their knees, and they have a certain shape of their knee, and then they need extra cushioning. And that to me would be doing things that I don't think you could do, or be very difficult for you if you did this like thousands of times, like you're saying. It'd be very difficult for you to quantify all of that experience as a model. So I think to me the exciting thing would be to really feed all the information back, and to try to say wait, there's 2 different people, one that really care about lightweight and one that care about cushioning or whatever, right? Mm-hmm. And finding new things that we didn't really assume previously. So to me, that's the way to go now, and to really have that. And then also, I would always say, let's have an onion layer kind of thing, and say the wizard just presses a button, and then the optimal happens. And then we have underneath it, you can make changes to the optimal based upon if you think that's exigent to do so.
Yeah.
That kind of onion layered approach, I think, would be the best. But I think definitely if you would try to start a business, you were talking before about the Zellerfeld thing, yeah, you're not going to get there with an automated AI or automated workflow for prosthetics. But helping all the people of the world with like low cost prosthetics done by AI, yeah, it could very much give you a couple of dozen million nowadays. You know what I mean?
Mm-hmm. Well,
and then, yeah, Brent has a completely different way of looking at this, of course.
You stole my thunder. I think yours actually. So we don't know what can be done with the data, but I think Ashton, what you're saying is let's get the data so we have it. Let's have it in a place to where we try to start to evaluate it, and then as the technology and the AI stuff, machine learning, all that stuff comes along, we're going to be ahead of the game. And I think that's the name of the game. And I think that's actually where, some of these big companies are going to have the advantage because they have massive data sets, scans, that sort of thing. And so once somebody cracks it, I'm sure that they'll get kind of gobbled up and nobody else will have access to it, which I hope doesn't happen. But that's my guess. I think the other side of this, and Ashton, I think you had a really good point on, there is a sense that you can, especially in the developing world, people can walk on about anything. And this idea of pain, tightness, that sort of thing. Hey, people are up and walking and they're like, this is the best thing ever. I think one of the things that people miss a lot in this whole process is the clinical side. And whether it's a prosthetist or a nurse or a doctor or whatever, there's two things that I think are very important. One is the initial evaluation of the patient, where you actually get like the tissue density, how they do the amputation, did they leave sharp edges, that sort of thing, and their diagnosis. But the second part of that, I don't care how it's made. It can be made traditionally, whatever. I want it to be cost effective. But the second part of that is the fitting. So the fitting is the hardest part, is getting the alignment right, making sure that they're not in too many socks, that they're not hitting certain parts of their bone and that sort of thing. And so I really feel where the education part misses is those two things, because I believe if you have those two things and they can communicate what needs to be fabricated, that's the real secret to this whole thing. The problem with our field, and Ashton kind of touched on it, is that we want control of everything, including the fabrication, and we will even do 3D printing poorly, but we have control. And that is a big mistake. And I think those people are going to get left behind anyway, or they're going to quit 3D printing altogether and then get left behind after the fact. And so to me, education side of this and let the AI stuff take care of the middle is perfect.
Yeah.
Okay, that's super cool, guys. I mean, I think this is a really exciting discussion. Generally, Ashton, I think I'd love to see how you get on. First off, with this whole workflow you developed, with just designing for this market, looking at it from a design / biomechanical engineer standpoint. How far you get on with that, and how far you progress with that. Also, I think we could also do another talk about Mexico, about that system of, hey, it's a country next to the U.S., but it's doing a lot of things very, very differently. So that could be also a very interesting discussion. So I'd love to talk to you again about this. And I thought it was really, really great to have you on the show today.
Yeah, thanks. I'm happy to talk about Mexico anytime. I love it here a lot.
Awesome. And thank you again for being here, Brent.
Yeah, I think this was great. And Ashton, thank you for sharing. We definitely have a lot more to dive into. So we'll definitely get Ashton on again. And I don't know how we let him get away with this, but he actually asked us question yours. Aren't we the ones supposed to ask questions?
No, it's good. It's good. Keep some weight. All right, Mom.
Hey, I'm always studying the industry. Got to take the moments.
Well, and actually, this is I'm glad you said that. So I think this is also very, very important. Is Ashton is not a clinician, but he has a massive passion for helping people and has a design set and skill to do that, but is also collaborating with clinical people. And I would say that's doing it the right way. So I think having that perspective and worldview, I really appreciate that. But I think it's also an encouragement to those that have some sort of background like what Ashton has and a passion to help people. There is room for you to make a difference in people's lives. You do not have to be a clinician. And I think that's a really important takeaway.
No, it's awesome. Yeah, I totally agree. I think it's a wonderful sentiment. And I hope you agree too, or disagree, but at least as long as you learned something that was a little bit inspired today, that'd be wonderful. And thank you again for listening to another episode of the Prosthetics and Orthotics podcast. Have a great day.